Alright, there, welcome back to Think Tank Online Learning. So in this video, I want to calculate the mass of a solid using triple integral. So we're given the mass of density, we're given density as a function of x, y, and z is equal to 2z over x squared plus y squared, or under the square root, occupies the region that is common to x squared, y minus 1 squared plus z squared is equals to 1, and z equals the square root of x squared plus 1. I want to calculate the exact mass of the material. So before we do anything, let's start by sketching this, and you have to remember that one space, so I'm going to sketch this in 3D. So what do we know? We know that x squared plus y squared plus z squared is equals to r. This is the equation of a sphere, right? And the center of the sphere is going to be 0, 0, 0. That is going to be the center point. And also know that x squared plus y squared, that is a cone. That is a cone. Okay, so with this information, we can solve our question. So what I'm going to do, I'm going to draw my xy plane. So this one will be z-axis, y, x. So I'm going to start by first drawing the cone, but you have to know that we're not given end bounds. So the cone is on the upper part and on the lower part. Okay, so I'm going to draw this cone. So this is going to be the cone, the upper bound of the cone. Okay, and it's going to be also on the bottom. Since it's the square root of a number, it's either positive or negative. Okay, so this one is the cone. Now moving on to the sphere. So the sphere, what is the equation of the sphere? So we know that the sphere is x squared plus y minus 1 squared plus z squared is equals to 1. Okay, from this you know that the radius is 1, but the center point, the coordinates for the center is going to be on x, it's x minus 0 here, it's 0. Then on y it's going to be positive 1. Then on z it's going to be 0. That is going to be the center. So if I say this one is my 0 and this one, let this one be equal to 1. So I'm going to draw a circle right here. Okay, then this is going to be the sphere that I'm looking for. So I say this equation is z equals to x squared plus y squared, or under the square root. This one is going to be x squared plus y minus 1 squared plus z squared is equals to 1. Okay, so the region that is common, let's shade it. This one is going to be the common region. We need to find the limits. So since we have x squared, the square root of x squared plus y squared, you know our density, we're going to use cylindrical coordinates. That's what we're going to use. If you're not familiar with the cylindrical coordinates, if you check in the description, I have a 53 minutes long video where I explained how to use cylindrical coordinates. I've explained this is way to evaluate units or to evaluate the limits when calculating the volume. So I think if you watch that video first and come to this one, that will be good. But if you know cylindrical coordinates, you're good to go. Let's go. Okay, so what do we know? We know that mass is equals to density over volume. That is the formula that we know from science, and it didn't change. It's still the same here. So mass is going to be the triple integral for the volume. Since we're in calculus V, we're going to have our density and we're going to have dV. Okay, so now let's look at the limits. We're going to look for the shadow. We're going to project our solid in the xy plane, and after doing that, we can evaluate the limits. That is going to be, that is the easiest way you can got this problem. Okay, so dV here. So I'm going to write this equation: x squared plus y minus 1 squared plus z squared is equals to 1. I'm going to call it equation 1. And we have z equals to x squared plus y squared, and this one is going to be equation number 2. But we're looking for the intersection. Since we're looking for the intersection, we're going to solve those equations simultaneously, 1 and 2, right? And if we simplify this equation, equation 1, I'm not going to show you step by step of simplifying. I need this to be short as possible. We're going to have x squared plus y squared plus z squared, and that is going to give us 2y. That will be equation number 1. Okay, now I'm going to sub 1, I'm going to sub 2 into 1. Because you know z squared is equals to square root of what? So that means if I remove the square root and if I remove the square root here, I'm going to have z squared equals to x squared plus y squared. And I'm going to substitute this into this. So for z squared plus y squared is equals to z, right? As you can see. So I'm going to have x squared plus y squared. And instead of writing z squared, I'm going to write x squared plus y squared. Okay. Let me just write what I'm saying here. So this one is same as x squared equals to x squared plus y squared. Z squared equals to x squared plus y squared. Okay, so I'm going to have x squared plus y squared plus, instead of writing z squared, I'm going to have x squared plus y squared, and that is going to give me 2y. And now I'm going to say 2x squared plus 2y squared, and that is going to give me 2y. Divide both sides by 2, I'm going to have x squared plus y squared. I'm going to bring out this y to this side. So now I'm going to complete the squares here. I have x squared plus y squared minus y is equals to 0. And I'm going to say x squared plus y squared. The quotient for y here is 1 divided by 2. That is going to give me half. And I'm going to square it. I'm going to have minus y plus 1 over 4. Then I'm going to remove this 1 over 4 and equal this to 0. And we're going to have x squared plus, and this one's going to be y minus 1/2 squared. And I'm going to put 4 right here. I know the equation of a circle is x squared plus y squared is going to give us r squared. So that means the radius will be equal to 1/4 under the square root, and that is going to give us 1/2. Okay? And the center point, what is going to be the center point of this? For x it's going to be 0, for y it's going to be positive 1/2. So let's sketch it in the xy plane. That is going to be the shadow. So this one is y, this one is x, and I'm going to assume that my 1/2 is here, and I'm going to draw my full circle. This one's going to be 1/2, meaning this one is 1, right? So this is the shadow of the solid if you project it in the xy plane. So from here you can look for the limits. So when you solve this equation simultaneously, we came up with this equation and solve them simultaneously. So I'm going to use this equation to evaluate limits for r. And as for theta, you can see theta ranges from 0. Let's rotate anti-clockwise, and it's from 0 to 2 pi. It's 0 to pi, right? 190 degrees. Then for r, we say x squared plus y squared. We have x squared plus y squared equals to y. X squared is r squared equals to 2r sine theta for y. So we're going to have r squared minus 2r sine theta equals to 0. Solve this using the quadratic. It's a quadratic equation. r minus 2 sine theta, that is going to give us 0. R is equals to 0 and r is equals to 2 sine theta. The limits for r ranges from 0 up to 2 sine theta. Okay, so with this, we now have our limits. Now let's look for z. Okay, so for z, you can check it directly here, but if you don't know, I'm going to sketch the yz plane. So I have the z, you can see, and I have y. So what do I have? I have the equation of the cone. So this is the graph of the equation of the cone, and I have this spherical part, and I'm going to shade this one. I'm going to do the same here. Okay, like this. And they've said this one is z equals to x squared plus y squared. And this is, what is this? This one is, they have simplified it here, and they say this one is z squared x squared plus y squared plus z squared is equals to 2y. So these are the limits. So I can see this one is same as this one. So if I find the area of the volume here, I just multiply it by 2. Now for z, you can see the equation of the sphere is going to be the upper bound, this equation of the sphere, and the lower bound is going to be the equation of this cone. So the equation of the cone, which is right here, so I say this one is the equation of the sphere, and this one is the equation of the cone. So the cone is x squared plus y squared equals to, under the square root is equals to z. So you can see this is r in cylindrical coordinates. So z ranges from r up to the upper bound, And the upper bound is x squared plus y squared plus z squared equals to 2y. Okay? And if we solve for z, you can see that z squared equals to x squared plus y squared is going to be 2r sine theta. So I'm going to have 2r sine theta minus r squared. Okay? And from here, you can see that z will be equal to the square root of 2r sine theta minus r squared. Okay, so let's write it as 2r sine theta minus r squared. Okay, like this. So this information, and what is going to be our density? Our density is equal to 2z x squared plus y squared or under the square root. That is going to give us 2z, and you are going to have r. And now it's time to calculate the volume. The mass is going to be the volume. So from 0 to pi for theta, then from 0 to 2 sine theta for the radius, and let's go for z. Say z ranges from, okay, so now I'm going to choose this upper bound, that just the top part. So z will range from the equation of the cone to the lower bound, and I'm going to call it, what is the lower bound? You say the lower bound is r, and the upper bound, the equation of the sphere, which is 2r sine theta minus r squared or under the square root. But this is symmetrical along the y, so I'm going to multiply it by 2 since I've introduced the bottom limits. And you are going to have, for the density here, said our density is 2z over r, and what is going to be the Jacobian? It's going to be dz and r dr d theta, and this r and this r we can go away, right? And here the mass is going to be from 0 to pi, 0 to 2 sine theta, and I'm going to say to differentiate z squared over 2, but we have a 2 here, so it's going to cancel each other. So I'm going to have z squared, and we no longer have r, from r to 2r sine theta minus r squared or under the square root, and you're going to have dr d theta. You know the square root of a number, or if you square root, you're going to get what is inside the square root. So from here you can say mass from 0 to pi, 0 to 2 sine theta. So we're going to have 2r sine theta minus r squared, and as lower bound you're going to be negative r squared, and we're going to have d theta. We're going to have dr, we have dr here, forgotten dr. So now I'm going to move on to this point. So the mass will be equal to 0 to pi, 0 to 2 sine theta. We're going to have 2r sine theta here minus 2r squared, minus 2r squared. We're going to have d theta. Okay, you can factor out 2, and remember I've forgotten to write 2 here. We have 2 here and we have 2 here, so still we have 2, and if you factor out 2 here, we're going to have 4, 0 to pi. Let's integrate with respect to r. We're going to have r squared over 2, and we're going to have sine theta minus 2. We no longer have 2 since we factored out 2, so we're going to have r to the power 3 over 3. We're going to have, put limits first, 0 to 2 sine theta, and we're going to have the theta. And what we're going to have 4, 0 to pi, and if you put 2 sine squared here, you can see we are going to have 4 sine squared theta, but we have another sine theta, so we're going to have sine theta divided by 2 minus, and we're going to have 8 sine cubed theta here over 3, and we're going to have the theta. So we can say 2 into 2, we're going to have 1, 2 into 4, we're going to have 2, negative 4 from 0 to pi, and you're going to have sine cubed theta minus, let me just simplify it, 8 over 3 sine cubed theta d theta. Okay, and we simplify, we're going to get from 0 to pi, and we're going to have negative 2/3. And what we're going to have here, we're going to have 2/3 sine cubed theta d theta, and we're going to have negative 8/3. And now it's time we integrate sine cubed theta d theta. Okay, so to integrate sine cubed theta d theta, we're going to write this as m as negative 8/3 from 0 to pi, and I'm going to write it as sine squared x sine x. Okay, I put in the x. Okay, let me just change it and write the x here, but it should be theta. Okay, and just use De Moivre's theorem and just find what is sine cubed theta. I think that will be easy. Okay, so we have negative 8/3 from 0 to pi, and sine squared theta same as 1 minus cos squared x sine x dx. And we're going to split this to negative 8/3 from 0 to pi sine x minus cos squared x sine x. This one's going to be the integral dx. So we're going to have negative 8/3, and for sine x it's going to be negative cos. So we're going to have negative cos x from 0 to pi, and here we're going to, let me just write it as cos squared x sine x dx. Okay, so I'm going to use u substitution here, because if you say cos pi, we're going to get negative 1, and cos 0, that's going to give you positive 1. 2 right here, so I'm going to have negative 8/3. I'm going to have 2, and for this one I'm going to let my u be equal to cos x, meaning du dx will be equal to, we differentiate cos, it's going to be negative sine x, and my dx will be equal to du over negative sine x. Okay, so we have our 2 here. We're going to have from 0 to pi, and for cos x it's going to be u squared. For sine x we're going to write sine x, and for dx it's going to be du over negative sine x. And you can see sine x and sine x goes away, negative and negative go away, for negative 8/3, 2 minus, and we're going to have u to the power 3/3. It's going to be plus here from 0 to pi, and that is going to be, here we're going to have negative 16/3 plus, this one's going to be cos cubed x over 3 from 0 to pi. And what is going to happen here, and if you say cos pi to the power negative to the power 3 is going to be negative 1, so this one's going to be the mass. So the mass is going to be negative 16/3. I'm going to have negative 1 here, 1/3. We're going to have cos 0, which is equal to 1 to the power 3. We're going to have negative 1. So it's going to be 16 remainder 3 plus 1 remainder 3 plus 1, and this one's going to be negative 20/3. That's going to be the mass. But the mass can be negative, we know that. But why our mass is negative? Everything is correct here, but the density is what caused our mass to be negative. You see, in some questions we're normally given the density as a constant, but no, our density varies, right? So that means our density affected everything. So that is the procedure. You calculate the volume. If we put a density as constant, just say 2 or 3, you get the correcting, so you get a positive number. But in this case, our density varies and it affected everything. So someone requested me to upload and show you the working, so this is the working, but the density have made our answer to be negative. But this is the procedure. The other way you can use spherical coordinates and you still get the same answer. So thank you for watching. Don't forget to subscribe.